On the 27th of August, 1883, the island of Krakatoa destroyed itself. The sound was heard 4,800 kilometers away on Rodriguez Island in the Indian Ocean, where the chief of police reported what he took to be distant cannon fire. It is still the loudest sound in recorded history, but it is not the loudest sound possible because there is a ceiling, and the reason for it has nothing to do with explosives. Sound has a maximum. It sits at about 194 decibels, and past that point sound stops being sound. First, the scale, because decibels are not what most people assume. The decibel scale is logarithmic. Every 10 decibels is 10 times the energy. A whisper is about 30 decibels. A conversation, 60. A motorbike at close range, 95. A jet engine from 30 meters, around 140. Which makes the jet sound like roughly twice the conversation. It is not. It is 10 million times the energy. And the gap from that jet engine up to the ceiling at 194 is another 54 decibels. 250,000 times more again. Nothing about this scale is intuitive, and that is rather the point of it. It was built for a range so enormous that ordinary numbers stop being useful. So what is a sound physically? It is a pressure wave. Air molecules bunch together, then spread apart, then bunch together again, and that pattern travels outward. Which means that at any point in the room, the air pressure is climbing slightly above normal, then dipping slightly below it, thousands of times every second. Loudness is simply how big that swing is. A quiet conversation moves the pressure by a few hundredths of a pascal against a background of about 100,000. You are detecting a change of about 1 part in 5 million. Your ear is an extraordinarily sensitive pressure gauge, and that same picture is what sets the limit. Before we go up, it is worth looking down because the bottom of the scale is just as strange as the top. 0 decibels is not silence. It is a definition, 20 micropascals, the quietest pressure change a healthy young ear can pick out. 20 millionths of a pascal against an atmosphere of 100,000. That is 1 part in 5 billion. At that level, your eardrum is moving by less than the width of a hydrogen atom, and you notice. So human hearing runs from 20 micropascals at the bottom to about 100,000 pascals at the top. A factor of 5 billion end to end. That is the real reason the scale is logarithmic. Written out in ordinary numbers, it would simply be unusable. Because the wave has to swing both ways. It rises above atmospheric pressure, and it falls below it. And the pressure of the air around you is 101,325 pascals. The wave can climb as high as you like, but it can only fall by 101,325 because at that point there is nothing left to remove. The trough of the wave has reached vacuum, and there is no such thing as less air than no air. Put that pressure through the decibel formula, and you get 194.1. That is the loudest a sound wave can be in air at sea level on this planet. Not because our instruments give up, because the air runs out. Push harder than that, and you do not get a louder sound. You get something else, a shock wave. The compression outruns the speed of sound. The smooth oscillation collapses, and what travels is a single moving wall of pressure. Which brings us back to Krakatoa, because Krakatoa was comfortably past this. At Batavia, 160 kilometers away, a barograph at the gasworks recorded a pressure spike that works out to roughly 172 decibels. 160 kilometers away. At the source, the number is meaningless because at the source it was not a sound at all. It was a shock wave. 64 kilometers out, aboard the British ship Narm Castle, the captain wrote in his log that he believed the day of judgment had come and that half his crew had burst eardrums. The pressure pulse kept going. Barographs all over the world recorded it passing, then recorded it again and again. It went round the planet between 3 and 4 times across the following 5 days. And the part that was still audible, still a sound, carried 4,800 kilometers, roughly Berlin to Kabul. For comparison, the loudest machine human beings have ever built is probably the Saturn V rocket. Measurements near the pad put it at around 203 decibels, which is above the ceiling, and that is allowed because the ceiling limits the trough, not the crest. The compression can keep climbing as high as you like. It is the rarefaction that runs out of air. Above 194, the wave simply goes lopsided, and lopsided is another word for shock. You will also read that the Saturn V melted concrete and set grass a light a mile away. It did not. A careful reanalysis in 2022 put the real figure far below the legend, which seems to have started as a number somebody once copied down wrong. It is worth being concrete about what these numbers actually do to a person. At around 120 decibels, sound becomes painful. At around 150, eardrums rupture. At 194, the pressure swing is a full atmosphere, arriving and leaving thousands of times a second. That is no longer a hearing problem. Blast at that level causes lung injury because the tissue between air and blood was never built to survive pressure changing that fast. Sound at the ceiling does not damage your ears. It damages you. There's a complication here, and it is responsible for a great many misleading headlines. You will read that a sperm whale click reaches 230 decibels, comfortably above the ceiling we just established. That is a real measurement. It does not mean what it looks like it means. Decibels are a ratio, not a unit. They always compare a pressure against some agreed reference, and underwater acoustics uses a different reference from air, 1 micropascal instead of 20. That difference alone accounts for 26 decibels. The different stiffness of water accounts for roughly 36 more. Correct for both, and a 230 decibel whale click is comparable to about 170 decibels in air. Extraordinarily loud, not impossible. And the ceiling underwater is far higher regardless, because the ambient pressure is higher to begin with, and it climbs as you descend. Down there, the air does not run out for a very long time. Which points at the part 1 find genuinely interesting. 194 decibels is not a fact about sound. It is a fact about air. The limit exists because our atmosphere happens to sit at about 100 kilopascals. Change the atmosphere, and the ceiling moves with it. On Mars, the surface pressure is roughly 600 pascals, about 160 times thinner than here. That drops the loudest possible sound to somewhere near 150 decibels. The Perseverance rover carries microphones, and in 2021 it recorded the first sounds ever heard from the surface of another world. Mars is a quiet place, and it is quiet by law, not by circumstance. There's a stranger detail still. In the carbon dioxide of the Martian atmosphere, high notes travel faster than low ones. Stand far enough from someone speaking, and the treble of their voice reaches you before the bass. And in a vacuum, the ceiling is zero. Not a very quiet sound. No sound. The wave has nothing left to be a wave in. So, how loud can a sound be? As loud as the room permits, and not 1 decibel more. The limit was never a property of the noise. It belongs to the air the noise is traveling through. Krakatoa did not break that rule. It simply stopped making a sound and started moving the atmosphere itself. This channel takes one number that is impossible to feel and makes it visible. If that is your kind of thing, subscribe. There's a new one every week.